So basically, we are going to discuss the metallurgy. Okay, in metallurgy, what happens here is that first of all, we extract the metals from the ores. Okay, ores. What are ores? Can you guess what are ores? Can you tell me what are ores? What are ores? Yes, Gianna. Can you tell me what are ores? Write down definition for the ores. Ores are the minerals from which metal can be extracted easily and conveniently. So write down the definition for the ores. Write down these definitions for the ores. That ores are the metals from which metals can be extracted easily and economically. Note it down. Definition लिखिए. और like for example, China के लिए is a mineral and bauxite is also a mineral. But if from this mineral we can extract the aluminium easily, economically. But if we extract the aluminium from China के लिए, it will be not economical. So that's why ores are those minerals from which metal can be extracted easily and economically. Note it down fast.
Done, sir.
Okay. Now when we have decided the ores, there are mainly basically four types of ores. कितने तरह की ores होती हैं? There are basically four types of ores. There are four types of ores. कितने तरह की ores होती हैं? चार तरह. First type of ore is sulfide ore. Sulfide ore. The second type of ore is carbonate ore. The third type of ore is oxide ore. And the fourth type of ore is halide ore. Now we are just talking about this sulfide ore and carbonate ore. Sulfide ore, like for example, which is having sulfur, like ZNS, PBS, AG2S, HGS. These are the sulfide ores. समझ आए? Carbonate ores like CaCO3, like ZnCO3. These are the carbonate ore, which is having carbonate groups. So it is very difficult to extract the metals from the sulfide ore and carbonate ore. So first we convert this sulfide ore into the oxide form. And there is a step called roasting. Roasting. And when we convert carbonate ore into sulfide ore, that step is called calcination. Calcination. So calcination and roasting. Can anybody in the class tell me what is calcination, roasting, and what is done in the cancellation and in calcination and roasting? Can you tell me fast? क्या होता है calcination roasting में? Can anybody in the class tell me what happens in calcination and roasting? बोलिए. सबके सब गूंगे हो गए हो भाई. Alvina, Gianna, Aisha, what happens in calcination?
It's a process where an ore is converted into an oxide by heating it at high temperature.
In the presence of oxygen or in the absence of oxygen?
In the presence of oxygen. In the
In
absence of oxygen.
carbonate ores are heated in the absence of oxygen, and sulfide ores are heated in the. Okay, when we heat the sulfide ores are always heated in the presence of oxygen. समझ आया? You
Yes,
got it?
sir.
So why Gianna is not able to answer this question? Gianna, why you are not able to answer this question? Please tell me. What happened in calcination and roasting? So in calcination, carbonate ores are heated to oxide form in the absence of oxygen. समझ आया? You understood? Like CaCO3, when you heat it, it will give you CaO plus CO2. Got it? Yes or no?
Yes.
Yeah.
Yes, sir.
And in if you are talking about the in sulfide ore or in roasting, what happens? The sulfide ore are heated in the in the presence of oxygen. In the presence of oxygen to get oxide form. For example, ZnS plus O2 will gives you ZnO plus SO2. Okay, note it down. Note it down fast. Can you tell me that why we are doing calcination roasting? Why we are converting it into the oxide form? ये आंसर मुझे जियाना बताएगी. I have joined through my phone. Means Jiana is not going to answer the questions today. Is that okay, Jiana? You will not answer? Abdul Kavi,
Yes.
why there is a need to convert oxide form? Sorry, why there is a need to convert carbonate ore and sulfide ore into their oxide form? Why there is a need? Why do we convert?
Hmm.
No idea?
No.
Alvina?
Sir, to remove the volatile impure material impurities.
और इसके अलावा? Yes, Aisha. Why have you turned off your? Why all of you are turned? Why have you turned off your camera? Please turn on the camera, everyone. Alvina, Abdul Kavi, and Aisha. Abdul Kavi, are you special?
No, my camera is not working.
Let me call to the team. So we will simply say that because oxide forms are easily reducible, reducible मतलब reducible means then their carbonate and sulfide form. Okay, because we can easily reduce. क्या reduce कर सकते हैं हम लोग? Because we can easily reduce ZnO to zinc as comparison to zinc carbonate to zinc. Okay, so if we have ZnS and we want Zn from Zns, it is very difficult. So first we convert it into ZnO, and then we can easily get zinc from ZnO. समझ आया?
Yes.
Similarly, we want to get calcium from calcium carbonate. So first we will heat it and we'll convert it into calcium oxide. Then calcium oxide further can be easily reduced to get calcium. Understood? You
Yes.
understood, Alpina?
Okay. Sir, can you say it once again? I didn't understand.
I'm saying that if you have zinc oxide, one is zinc oxide, other one is ZnS. I ask you which from which you can easily get the zinc. So it is easier to extract zinc from zinc oxide rather than zinc sulfide, because
Yes.
oxide form is easily reducible. You can easily reduce means removal of oxygen. So you can easily remove this oxygen and you can easily get the uh, okay, zinc from it. Similarly, if you have calcium carbonate and you have calcium oxide, I ask you from which you can get calcium more easily. So you will get calcium from calcium oxide rather than others. Okay, understood? Yes or
Yes.
no?
Yes, sir.
So it is an important question. Now, when we have converted, now we have generally sodium, calcium, sodium, sodium, calcium, magnesium, aluminum. Up to here, they are considered to be as highly reactive metals. Highly reactive metals. ओके, अगर ये आपने ये जनरली कैल्शियम क्लोराइड की फॉर्म में पाया जाता है, दिस इज फाउंड सोडियम क्लोराइड. ये कैल्शियम, दिस इज फाउंड इन कैल्शियम कार्बोनेट, बट व्हेन यू डू द रोस्टिंग इट विल गेट कन्वर्टेड इनटू CaO. Sorry, when you do the calcination, so this calcium carbonate will get converted into CaO. Similarly, magnesium is also present in the form of magnesium sulfide or magnesium carbonate, but when you do either roasting or calcination, you will get magnesium oxide. Similarly, aluminum is present in the form of Al2O3, already in the presence of Al2O3. So if you want to get the metal from this potassium, sodium, potassium chloride, sodium chloride, calcium chloride, and magnesium oxide, and aluminum oxide, you have to do one thing, that is electrolytic reduction. Electrolytic reduction. So highly reactive metals can be converted into their from their oxide form into metals, or from their halides from into metals, when we do the electrolytic reduction. Electrolytic reduction means we require electricity for it. Understood? Understood?
Yes, sir.
Next, when we have, like we have potassium, standard. Next is metal blue aluminum, we have chromium and manganese. So if you have chromium oxide or manganese oxide, they are reduced by aluminum. We are reduced by reduction with aluminum. And below iron, we have carbon. I'm just placing carbon here so that you can understand. This is iron, zinc, iron, tin, lead. Their oxide form, like you have zinc oxide, whether it is found in the form of zinc carbonate or ZnS or zinc carbonate. So first you will do the roasting, you will get ZnO. First you will do the calcination, you will get ZnO. Now if that ZnO, you want to remove the Zn, you want to get Z, simply oxygen, sorry, you want to get Zn from ZnO, so you have to reduce it with carbon, with the help of carbon. Similarly, if you have Fe2O3 or Fe3O4, you have to reduce with carbon. Tin oxide, SnO2, and PbO. So any one of them, if you are having, they can easily be reduced with the help of carbon. So these are called mid-reactive metals. Mid-reactive metals. Mid-reactive metals. And they are reduced by with the active metals and they are reduced by iron, sorry, carbon. समझ आया? You understood? Understood?
Yeah.
And then after the lead, we have hydrogen and then we have mercury. So mercury, if it is found in the form of HGS, and like copper, if it is found in the form of Cu2s, silver, if it is found in the form of Ag2s, and like we have another golden plate. Okay, these metals, so they are reduced by simple heating. Simple heating means क्योंकि ये सब सल्फाइड फॉर्म में, तो we can use it by simple roasting. If you heat it, you can easily get the metal. There is no require of carbon, only the metal. These can be easily removed. And gold and platinum, they don't require, they require directly refining, so they are exist in free state or native state. Exist in and free or native state. समझ आया? Note it down. जल्दी लिखिए सब कुछ एक ही चीज फटाफट से हेडेक में. When you done, please let me know. You done?
Yes.
Everyone noted? Alvina, Abdul Kavi, you noted?
Yes.
पूछूं
Yes,
फिर?
sir.
Okay, बताइए. Zinc is reduced with the help of action of zinc. Means
Carbon.
if you have zinc oxide, how can you get the metal from it? Tell me. Which reducing agent is being required?
Carbon.
Carbon. If you have aluminium,
Electrolytic reduction.
electrolytic reduction.
Reduction.
If you have uh, zinc sulfate, sorry, if you have like NaCl, Then
Electrolytic reduction.
electrolytic reduction. Okay. And if you have mercury, HGS,
Roasting.
hmm?
Roasting. It will be done by
Simple,
roasting.
simple roasting.
Simple.
Okay. So here are the reactions for each and everything. So for practice, please write down these one. The most important and the very important is this one, the copper reduction. Okay. Because in this, the sulfide, the crushed ore itself behave like a reducing agent. Okay. So wrote it down Ag2O when react with this one. Ag2S plus O2 will gives you Ag plus SO2. Ag2O when you heat it, it will gives you 4Ag plus O2. Then this one. Okay. Note it down fast.
Done, sir.
Just a minute. So you done, everyone? Okay, now, so it is the only case where the ore itself behave like a reducing agent. Okay, the ore itself behave as a reducing agent. Got it? It is the only case when Cu2s. This is an important question, very important question. देखो, अभी मैं फिर से बोलता हूँ. Like if you have Hg2s, your HGS, cinnabar we called it. When it react with oxygen, and when we do the roasting, we require oxygen. To heat it, it will give you simple HgO plus SO2. And when you further heat HgO, it will give you Hg plus O2. But if you have copper, Cu2s, when you heat it in the presence of oxygen, it will give you Cu2 plus SO2, like the same, यहाँ पे ऐसे मिला है. But if you heat Cu2O, it will not give you Cu plus O2. ऐसे नहीं देगा. Okay? It is not an easy task. ऐसे नहीं मिलेगा. So for this, we require Cu2O, we require either carbon. अगर कार्बन है तो Cu plus CO2 आपको मिल जाएगा. But since if this ore is already present in the container, अगर ये ore already present है container के अंदर, मतलब थोड़ा some of the particles are converted into this one. Now this particle will react with the crushed ore, Cu2s, and then further it will gives you Cu plus SO2. उसमें दोनों केस में SO2 मिलता है. Okay. Otherwise, in the case of silver and mercury, we get O2 in the second equation. Got it? Understood?
Yes.
Okay. Next. Now, if you have Cu plus O2 gives us CO2 equivalent. Now, what is smelting? Smelting is reduction with carbon. So, mid-reactive metals are reduced by this one. Now, this is a very important reaction, that is a thermite reaction. Aluminothermy is the process of reduction of metal with the metal oxide with the help of aluminium. Like this one. Like this one. And this reaction is so exothermic that the heat liberated out during this reaction, the metal obtained is in the liquid state. Means that it's enough to melt the metal. So, manganese here and chromium obtained is in the liquid state. Liquid state. ये liquid state में ऑपरेट होता है. समझ आया? Okay.
Yes, sir.
But if we are having Fe2O3 plus Al, okay, Fe2O3 plus Al. You multiply, you remove this one, you will get Al2O3 plus Fe. Got it?
Yes, sir.
Fe in the liquid state. The reduction with aluminium is an exothermic process. The heat liberated out during this reaction light the metal obtained in the form of molten form. In the molten. Okay. So note this statement. This is a thermite reaction. That this is the thermite reaction. Fe2O3 plus Al gives you Al2O3 plus Fe in the liquid state. You know that Fe is the mid-reactive metals. Fe comes in the mid-reactive metals, and oxide of Fe2O3 can easily be reduced with the help of carbon. You get Fe plus CO2. But in this reaction, you have to heat this metal, it becomes in the molten state, and then you have to add the carbon powder to it. But if you have Fe2O3 in the powder form and aluminium in the powder form, and then you ignite it with the help of burning magnesium ribbon, then the reaction will start and you will get Al2O3 plus Fe in the liquid state. The heat liberated out is so large that the metal obtained in the liquid state, which is joined to which is used to join the railway track. This comes here. Okay, समझ आया?
Yes,
Yes.
sir.
Yes.
Note it down this one. Note it down first. You done? Done?
1 minute, sir.
Hmm?
1 minute. Done, sir.
Electrolytic reduction. What is electrolytic reductions? When we are doing the electrolytic reductions, okay, during that time we have to keep in mind one thing, that during the electrolytic reduction, okay, if we are talking about the electrolytic reduction, then you have to keep in mind that during electrolytic reductions, the only pure metal ore is we are just going to have, and it should be in the molten state. Like for example, if you want to get the aluminium, so aluminium oxide should be in the molten state in the container. And these are the inert electrodes, that is of graphite. Graphite electrodes, okay, graphite electrode, we called it inert electrode, inert. Okay, graphite electrode we're going to have, graphite electrodes means दोनों ही graphite की हैं. और इसमें अगर आपको if you want to obtain, okay, so this is Na positive and like Cl minus. So when you have molten in the molten state, the Na and silver ion or chloride ion will get, okay, like for example NaCl, if you have this one in the liquid state and you pass electricity to it, then it will gives you Na solid plus chlorine gas. Got it? Because Na ना split कर जाएगा in the liquid state में. Got it? Because it will get converted. So at anode पर क्या होगा? At anode. So can you tell me that which gas is or which substance is obtained in the anode in case of, means sodium will be obtained at anode or chlorine will be obtained at anode? Can anybody have?
Chlorine.
Huh? Which
Chlorine will be obtained at anode.
chlorine will be obtained? Yes, chlorine. So the two Cl minus ion जाएंगे और they will convert it into Cl2 plus 2 electron को lose कर देंगे 1 1 each, because it is having Cl minus means extra electron. So when they will lose 1 1 electron each, then they will combine together and form chlorine gas. Similarly, at cathode per, what would happen? The two Na plus ion will goes and they will obtain 1 1 electron each. They will get 1 1 electron each and will convert it into Na solid, 2 Na solid. Don't write N into Na2. Na2 नहीं होता कुछ भी, okay? मेटल्स में नहीं लिखा जाता ऐसे। ओके, कॉपी करो इसको, थोड़ा सा देख लो। इलेक्ट्रोलाइटिक रिडक्शन, इलेक्ट्रोलाइटिक रिडक्शन। So electrolytic reduction is done for, can you tell me? Electrolytic reduction is done for highly reactive metals, जबकि electrolytic refining किस में की जाती है? लो reactive metals के लिए। ओके, will you keep this one in mind? Electrolytic reduction is done for electrolytic reduction is done for, tell me.
Highly reactive method.
Hmm?
It's done for highly
Highly
reactive method.
reactive metals, highly reactive metals. Okay, while electrolytic refining is done for, while electrolytic refining is done for, done for what? Low reactive or mid reactive metal? Low reactive or and mid reactive metals. Okay, समझ आया? Got it?
Yes, sir.
Can you tell me that when we are doing the electrolytic refining, we are on which, Aisha, why have you turned off your camera? Are you there in the class, Aisha?
Yes.
So, Alvina, can you tell me that where is, when we, let's suppose we are doing the copper, refining of copper, the refining of copper. So can you tell me where do we take the impure metal of copper? Tell me, where do we take the pure metal of copper?
At the anode.
Yes, impure metal rod is made as anode. Okay. Impure metal rod. And a thin pure metal rod is made as, tell me, cathode. Thin pure metal rod. Thin pure metal rod. Okay, now when we are passing high voltage current to it, and the electrolyte, what is the electrolyte that we are going to take? Uल्टा कर दिया. Can you tell me
Sulfuric acid.
which electrode will take here? Which electrolyte? If we are refining the copper, we'll take copper sulfate plus a small amount
Copper sulfate.
acidified. Means we can take the small amount of H2SO4 also. Okay,
Yes, sir.
understood?
Yes.
Yes, sir.
And at the end, this whole, you will see that the Cu2 positive ion from here will be deposited here. So at cathode, Cu2 positive ion will get 2 electron and will get converted into copper solid. And at anode, this copper atom inside S1. Cu atom, मतलब इसका reverse लिख देना है बस. Cu solid will get converted into Cu2 positive plus 2 electrons. समझ आया?
Yes, sir.
तो note it down, या बना लो, करा था, बना होता है. Note it down. You done?
Done, sir.
Yes, you also. Okay, so in the next class, we're going to discuss questions. Just a minute. Let happen. Class. Just a minute. Yes, what would be the correct answer? Question number 36. Rina, and you, everyone.
Sir, option C.
Option
C.
C. Yes, option C is the correct option. Because Cu2 positive ion will go from anode to cathode. Here it is going from cathode to anode, and here it is going from anode to cathode. But the impurities will also will lie below anode, not cathode. And here it is going from anode to cathode. It is correct. But here anode is connected with negatively charged. It is incorrect. Anode is positively charged. So that's why only C is the correct option. Okay. Got it?
Yes, sir.
Question number 38. What would you answer? Question number 38. Done. Question number 38. What's the answer for question number 38, Alvina?
Sir, for the A1, Impure silver will be taken at anode and pure silver will be taken at cathode.
Okay, and electrolyte,
Silver sulfate, Ag2SO4.
electrolytic cell.
Pure silver will be obtained at cathode.
Okay, so that's all for today. We'll meet in the next one. Thanks for coming. Okay. So, dear ninth students, I'm just going to start in 2 minutes. Let me drink some water. Okay, just coming back. Yes, everyone, how are you? I'm audible to you.
Assalamualaikum, sir.
Hello, Salam. Anam, I am having an issue with you that why you used to leave the class earlier, 20 minutes earlier, 25 minutes earlier.
So
Just have it.
sometimes it was a bit urgent, like a phone call would come. And nowadays, some issues have been happening in my Zoom. So it has been happening in my physics and other subjects classes as well. But I'm trying to get it fixed.
So I was just thinking that Anam is not, means I'm not expecting you to leave the class in the middle. You know that if you know any answer perfectly or any chapter perfectly, does not mean that you are just going to leave without informing me, okay? So please
Yes,
keep
sir,
in
but
mind
it's
for the
not
next.
intentional all the times.
Okay. So everybody please turn on your camera. And the next chapter is the atoms and molecule that is going to come in your examination. So let's discuss that atoms and molecule.